Hey everyone, and welcome to a new episode of He's Not Wrong. I'm your host, Chad D, and I'm so excited for this episode. This one's been a long time in the making. I actually have the book that this episode is about right behind me. It's called Becoming Martian: How Living in Space Will Change Our Bodies and Minds. It's written by Scott Solomon with a foreword by Scott Kelly. I'm excited for this episode, so I want to pose you a question. What happens to the human body and the human species if we actually leave Earth and not just visit Mars, but we settle there and we stay? That's the question at the heart of today's conversation. As I said, my guest is Scott Solomon. He is an evolutionary biologist at Rice University and the author of the book that I just mentioned, Becoming Martian. Scott studies how species change over time, and he's turned that lens onto the most audacious question of our time. Not just whether we can get to Mars, we know that we can, but what happens to us once we're there? What we eat, how we're born, how our bones change, whether after enough generations, the people living on Mars would even be the same species as the rest of us back at home on Earth. This is one of those conversations that starts, with rockets and space camp in fourth grade and all the fun things, and it ends with what it means to be a human. We end with morals and ethics, and have we actually thought through what it means going to Mars? This episode, it means a lot to me. Like I said, it was a long time coming. I've been so excited to give it to all of you. I hope you enjoy it. So without further ado, I give you my conversation that has been long awaited for me with Scott Solomon. Scott Solomon, thank you so much and welcome to He's Not Wrong. I'm so excited to have you on today. How are you doing?
Hey Chad, I'm so good. I'm happy to be here, excited to chat with you, and yeah, I'm looking forward to it.
So before we get into talking about your book, Becoming Martian, I'm completely obsessed. I told you before I pressed record that I'm absolutely geeking out about this episode. But I wanted to ask you before we really get into the book, I want to ask you, have you seen Project Hail Mary?
Oh, I have. Yeah, I saw it. I actually saw it sneak preview before it came out. I was very excited to see it. Yeah.
How did you land that one?
Well, it wasn't anything particularly special. Amazon had like a promotion going for Amazon Prime
Oh,
members.
nice.
And so I got to see it like 3 or 4 days before opening night, but I was still pretty excited about that. So yeah, no, it was super cool. I enjoyed it. What about you?
And I did see it, and I'm obsessed with that movie. I want to go see it a
Yeah.
second time. I've been telling everyone it is the best movie that I've seen in a long time. The writing is phenomenal. I did not read the book, but I have ordered it, so it should be coming in anytime now because I want to read that book now. But one thing that in reviewing your book that brought me to Project Hail Mary is this idea of the vastness of space and looking
Yeah.
at Project Hail Mary. One thing that I think that they did beautifully was just showing how isolated you are when you're up there. And so just the parallels between what Hollywood did and then what your research and
Yeah.
your writing showed, it was brilliant.
Oh yeah, yeah, thanks. Well, also to me, the thing that I really like, the connection I made back with, the stuff that I've been working on is just the human element, right? Like it was a
Yep.
human story, and an alien story, spoiler alert. But, but basically like it's about the importance of people and I mean, well, Ryan Gosling was fantastic and and the others as well, but like it was really centering like the importance of having a person going and having this, adventure experience, trying to save the world, all of that.
Yeah.
To me, that was, like we have to think about as we think about space and space science and space exploration, there's a lot we can do without humans, but at
Yeah.
the end of the day, what people are going to care about is when there are people involved. And
Yep.
that is the thing that I try to do in my writing and talking about this topic now is make that really central. It's about people.
Knowing that people are central to that story and essential to space exploration and science, what impact do you think Artemis 2 and that mission had on the people aspect? Because I feel like for so long it was just you saw SpaceX going up every so often, and a human element of it was removed, and there's just this like humanity that came out of Artemis 2 that I have not seen in a really long time, and it just felt different and it felt special.
I agree. I mean, I think that is really the thing that made the Artemis 2 mission so impactful was that it was we all got to experience it through the eyes and voices of those four
Yeah.
astronauts. And to be fair, they did such a great job of being a vessel for all of humanity, right? Like,
Yep.
they were so willing to kind of share the experience in real time. But then, like, since they've been back, like, I've been, closely following all of the kind of media that they're doing. And they're so good at really, like, being human, right? And talking about what was it really like for them. And they're really open to kind of like sharing the experience. And yeah, so I think, look, people have been going to space, that never stopped.
Yep.
But part of it was how open and how accessible they were, I think. And the other part of it was, of course, the destination, the fact that they were going around the moon, that we got these views from the far side of the moon, looking back at Earth and seeing the moon itself. And that aspect of it was cool. But it was made so much cooler by them experiencing that, right?
Yeah.
Like hearing what they thought it was like in the moment. There was one, I don't know if you caught this, but there was one moment in which, I forget which of them said this, but basically somebody said that it was like they went sci-fi. That was the comment. They were saying, this is so cool. The views are amazing. And then it was when the eclipse happened, when they were experiencing the solar eclipse, like the moon was blocking out the sun from their perspective.
Yep.
And I mean, for them to say that it's now sci-fi, just think about that. Like all of this feels like sci-fi, right?
Yep.
Here they are in space, they're going around the moon. But that was the moment when to them, it went to the next level. And so I thought that really kind of emphasized how much their experience transformed the way that we all experienced it.
Yeah, absolutely. I've thought several times since then, like how do you like what does that processing that look like? You come back to Earth, you're doing all these interviews. Like at what point do they just sit back and go, I saw that. Like I was that far away. I don't know how, if I had that opportunity, if I was on that spaceship in that capsule, I do not know how I would process that coming back to Earth or what that would be like. That is such a taboo thing. I'm like, it's crazy.
Yeah. Well, and another one, I think this was Jeremy Hansen that said this in an interview, like, a week or so after they got back. Somebody asked him a question about what it was like. And he gave a very honest answer, which was like, I'm actually still processing it. Like he actually couldn't really say. He was acknowledging that, like, it's going to take me some time to reflect on this experience before I can really give you a full answer. I thought that was very honest of him.
Yeah. So I live in Birmingham, Alabama. I'm about an hour south from Huntsville. I grew up in Montgomery. So growing up, went to space camp, saw the moon rocks, and in the fourth grade saw the Saturn rocket that they have on display up there. Like space and science was integral to my upbringing. And I've always said that I would be an astronaut if I was good at math. Unfortunately, I'm not. So,
I mean, these days you don't have to be good at math to be an astronaut. I got news for you, Chad. You might still have a chance. Like it's becoming more and more possible for a lot of people to go to space. Yeah.
Thank God. I'm gonna have to look into some of those opportunities for sure. I don't have the $250,000 or however much it costs to go on the Amazon rocket, but maybe sometime soon it'll be more accessible.
They need podcasters too, right? I mean, think about the
content creation,
right? Yeah, exactly. Yeah.
So I know for me that love for space stemmed from having access to the U.S. Space and Rocket Center in Huntsville, and that really instilled this love for space exploration and science in me at such a young age. At what point in your life did it become a passion for you? What piqued that interest?
Yeah, I mean, I think like you have also always had a fascination with space. I mean, I was sort of like a general science geek. Like I really was somebody who was always fascinated by all aspects of science, whether it was, seeing dinosaurs in a natural history museum or catching bugs in my backyard or, watching, space shuttle launches on TV or whatever. All of that. Also, I had, grew up visiting Houston. I live in Houston now, but I'm not from Houston, but I did have family in Houston as a kid, and we would come here regularly and go to, NASA Johnson Space Center and like what you're talking about, seeing the rockets, seeing the facilities where, astronauts are training, all of that definitely, left me with a sense of awe and wonder. But I sort of went in a different sort of science geeky direction. Like I gravitated towards the life sciences and biology and
Yeah.
nature and became a biologist, which that is its own separate sort of story, origin story there. But so I came back to space kind of in a roundabout way because I was really thinking about evolution and how evolution works on Earth, and then human evolution and how we're still changing today and how we might change in the future. And that is the kind of thing that got me around to thinking about space exploration again from the perspective of an evolutionary biologist, which I think is kind of different from how a lot of people think about space, right? Like I'm
Yeah.
thinking, well, what happens if we actually live on other worlds? Do we like
Yep.
know what would happen to those people? So that for me was my evolution, in which I kind of like always was fascinated by space, but came back to it as a
Yeah.
as an adult, basically rediscovering my childhood interest in space, but through the lens of a biologist.
Yeah, that's awesome. And the next question that I have for you, we're gonna get into evolution and what we know, what we don't know. Um, but this question is really I'm giving the people on social media what they want with this one, because I always fall down this rabbit hole, and there's so many discussions surrounding Leica, the space dog, if I'm saying her name right. From
Yeah, yeah,
I
like yeah.
remember, yeah,
Hmm.
I remember learning about her in fourth grade, in fifth grade, sixth grade, seeing photos and learning about her at space camp in Huntsville, Alabama. But it never really dawned on me that like they literally like found this dog on the street
Yeah.
in Russia. They sent this dog up into space, and it was essentially tortured. It had no idea what was going on. There wasn't a lot of science around sending living beings into space back then. Did we really learn anything from sending her up into space? And I want to ask this question following that theme in your book, that there is still so much more to know
Yep.
before we can even like populate another planet in our solar system. So I'm just curious, even from back in the 50s when they did that project, like did any actual like learnings come from sending her up there?
Yeah, it's a great question. So Laika was the first animal in space, and so we have to go back to that time in which no, since no living thing had been to space, there were basic unanswered questions about whether any living being could actually survive in space. And of course, the major question was, could a person survive in space? But neither the United States nor the Soviet Union, which were the two countries that were really, able to send a rocket to space at that time, neither of them knew whether a person could survive in space, and neither of them was willing to send a person before having some basic reassurance that
Yeah.
that it wasn't going to immediately kill them. So the Soviet strategy was a bit different from the American strategy. The Americans decided to use primates as their research subjects.
Yeah.
I actually had a whole chapter that ended up unfortunately getting cut from the book because of space constraints, but it was really kind of diving into this history, very sad history of animals as research subjects in the early days of space exploration. Maybe it's good that it got cut because it was really depressing, but I feel like it's important to know,
Yeah.
like these animals made a sacrifice, and I think, there were examples of experiments where nothing was learned, and those are really tragic. But a lot of them did incrementally, slowly kind of get us a little bit more insight. And so you have to
Yeah.
remember that like what we were doing in the US and what was happening in the Soviet Union, they weren't sharing information, right? So in some ways, they were sort of replicating the same type of thing. So some of the early primate experiments that the U.S. didn't necessarily, inform what the Soviet Union was doing, although we were more open about it than they were. So when they sent Laika, this was basically, they had just sent Sputnik, the very first ever satellite, into space, and it orbited the Earth. And the next step was to send something like Sputnik, another satellite, but with a living being. And as you said,
Yep.
they took dogs off of the streets of Moscow. These were stray dogs. They trained them, and they chose dogs because dogs are easily trainable and can, basically you can get them to sit still in a confined space for a while. So what Leica taught the Soviets in particular, was that space was not immediately lethal.
Yeah.
Leica did not survive long, but she did survive being in space. I don't know if it was hours or minutes or exactly how long it was. There was never a plan for Leica to be returned to
Mm.
Earth, but they did expect that she was going to survive longer than she did. But they were monitoring her, and they were able to, see that, like, being up in space, she was still alive for a
Yeah.
while. And so that actually did show that, okay, the conditions of space are not immediately lethal to a living being. Nobody knew, right? That was a possibility.
Yeah.
So yeah, so it is a sad case for sure. And she's, rightfully famous in the history of space exploration. But yeah, it was, unfortunately a sad case.
Yeah, back then during that space race, it was between countries, but now I feel like the modern day space race is between public entities and private entities. And I don't know if that's a fair assessment. That's how it feels
Yeah.
like it's playing out right now. Is SpaceX going to go to Mars first? Is NASA going to go to Mars first? Are they going to go to get like
Yeah.
it's go ahead.
Well, it's interesting because there's some of both actually. So yes, you're right that there is a lot of competition between various private companies to try to kind of do a little bit more than what the other company is doing. And in particular, like, you can take SpaceX and Blue Origin at the moment are competing for being able to develop a lunar lander, right?
Yeah.
NASA wants to go back to the surface of the moon. NASA does not have a spacecraft that can land on the moon. So they have contracted with two companies on purpose to create competition. And that is Blue Origin and SpaceX, who are both trying to develop something that can be a lunar lander for the Artemis 4 mission, which is currently scheduled to land on the moon in 2028. So yeah, that is definitely happening, and there's lots of other examples of companies that are competing with one another. But there is still the national space race element to it, and it's largely between. Well, first of all, there's many more spacefaring nations today than there
Yeah.
were back in the 50s, 60s. But at the moment, sort of the biggest kind of players in racing, particularly to get back to the moon, are the U.S. and China. And the U.S. has many allies in doing this, including in Europe, the European Space Agency, the Japanese Space Agency, and others. The Chinese Space Agency has some allies as well, but those are sort of the biggest players at the moment. And so there is that component to it. And if you look at sort of how does NASA continue to push to get more funding and all of those things that they're trying to do, part of it is this idea that we are in a competition with another nation to
Yep.
try to do things like build a base on the moon.
Do you think that timeline? Well, after Artemis, right before Artemis 2 went up, they pushed back the timeline for going back to the moon. Do you think the timeline that we're on right now is they're going to be able to stick to that? Because they don't even have a lunar lander solidified yet, as you said.
Yeah, they're so right. So the lunar landers are in development. So they didn't actually push back the date for the lunar landing. What they did was they added another mission in between Artemis
Got
2, the
it.
one that just flew, and the moon landing. So the moon landing was already scheduled for 2028, and these dates are tentative. Like, they do tend to get modified, but 2028 was the date. And then what they announced, what NASA announced, is that they are going to insert an additional mission, Artemis. Basically, it pushes the numbers back. So what was going to be Artemis 3 is now Artemis 4. And the new Artemis
Got it.
3 is now a rendezvous in Earth orbit. So not as far as the moon, but closer to Earth, in which the spacecraft that they launch from, just like what we saw with Artemis 2, like that launch vehicle will rendezvous in space with the lunar lander. Now, we don't know what the lunar lander is going to be. Is it going to be what SpaceX is developing or what Blue Origin is developing? And so, it could be that they actually test both during that mission, if both are available, or if only one is available, then that's what they will test. But yeah, so that's scheduled currently for 2027. It was initially sort of middle of 2027, and they recently, it sounds like it's being pushed to sort of later in 2027. But of course, it is dependent on that lunar lander being ready.
So I just want to make a jump here because we're talking about going to the moon, but do
Yeah,
you like genuinely in our lifetime, do you think we will see humans on Mars? And I have a point to
I
this
do.
question.
Yeah,
You
I
do.
do. Yeah,
Okay.
yeah, I do. I think we will see humans setting foot on Mars. I do genuinely think it is realistic to expect that that will happen within certainly within the next few decades. It could even be as soon as within the next decade. I do think that that is within the realm of possibility and possibly even likely. And part of the reason why I say that is because of all of the races that we were just describing, both the
Yeah.
national space races and the commercial space races. There's enough competing interests here. The technology is not far off. I mean, we've been sending, landers and rovers to Mars, pretty consistently in the recent past. And so, yes, it's more complicated to send people for a variety of reasons that I'm sure we'll get into, but we're not so far off in that technology. So I think it's definitely possible.
You brought up the rovers that we've sent to Mars. One of the most shocking things that I did not realize until maybe this past year is like the actual distance that they've traveled on Mars. For how
Oh
long
yeah.
they've been on Mars compared
They
to the
don't go very
distance that
fast.
no.
No, that's true. Yeah, they go slow. But yeah, but it's just remarkable how long some of them have lasted. You've got rovers in some cases that were designed to last months that have lasted years.
Yep.
They're tough, and man, the folks that build those and run them are really impressive. Yeah, yeah. So yeah, I was really lucky to get to sit in on some of the science meetings that the Perseverance rover, which is the most recent rover that was sent to Mars. They have these meetings every day where they have to make decisions about where are we sending the rover today? Well, tomorrow,
Yep.
because they have to send the instructions and then it'll go the next day. And then, they're able to see basically in real time, like where the rover is, and they can see such high resolution images down to like a grain of sand. I mean, it's absolutely amazing. And then they're basically driving this rover around, like they're sending it, okay, we want to go to that rock there. We want to take a close look at this grain of sand here. We're going to collect this sample. So just being a fly on the wall as they were having these meetings and discussions was absolutely mind blowing. It was one of the coolest things I got to do.
How do they interact in those meetings? Like what is the language that they're speaking? Are they just like so super laser focused on what they're doing? Like I just have zero concept for
Yeah.
that level of intelligence and skill set and all those people being in one space. Like I can imagine how insane that is to
So,
experience.
yeah, I mean, that was part of why I wanted to sit in on it because I also had no idea what to expect and I wanted to just sort of like capture it. So, a lot of what I try to do in the book is not just tell people what do we know, but show them like what is the process that is going into this research, right? And so
Yep.
this was a good example of that. So, first of all, they're not all in one room. It's actually like a Zoom call. I don't think it was Zoom, but it was something like Zoom. So basically, it felt kind of familiar in a weird
Yeah.
way in that you're on, basically I was in this is my colleague, Dr. Kirsten Seebach. She's a geologist that studies Mars, and she, kindly invited me to sort of be able to tag along with her in some of these meetings. And so, yeah, basically it looked like her in her office with her computer screen up and a call, not so different from what you and I are doing now, except with a lot more people on it. And so, part of what was fascinating was just the way that functions, right? So they have, different folks who will chime in at various times. There's somebody kind of leading the call. Folks will chime in or add something to the chat or to the shared document they're
Yeah.
working on, basically making proposals where somebody will say, I would like to propose that we go and look at this rock on the screen here, and then they'll have a discussion about that. And so there's this kind of process. It's really an impressive process in many ways of collective decision making. And they each have their own kind of things that they're more interested in, their own sort of priorities, their own agenda, if you will. But
Yeah.
they have to work together to make decisions because at the end of the day, the rover can only really take one path. You don't want to backtrack, and so you got to keep
Sure.
moving forward and make decisions. So I tried to capture a little bit of that in it's in the first chapter of the book, or
Mhm.
in, including some of their dialogue and just a little bit of sort of what it was like to experience, because I was so fascinated by being able to observe that.
It's so crazy to me to hear that they're a lot of it's virtual. They're on systems like Zoom communicating because
Yeah.
even though they're scientists and engineers, there's a level of creativity that goes into that, and or
Oh, for
a
sure.
lot of
Yeah.
creativity that goes into it. They're very creative people for what they do, and to know that they're not in person. Just with like my idea of creativity, it's like I'm most creative when I'm with people, and they're
Yeah.
able to be that successful with their skills remote. That is
Yeah.
fascinating.
Well, and it's a good example of how technology is allowing us to do things that just wouldn't have been possible
Yeah.
even, not that many years ago, right? Like it would be very different if all these people had to be together in the room constantly. It would be disruptive for all the other things they're trying to do with their lives, right? So just,
Yep.
we've normalized that today, so nobody's going to be surprised by the idea that we can have a call with a lot of people on it. But the fact that we can do something as complex as drive a vehicle on another planet, it really is still pretty remarkable to me.
I asked you, do you think we'll go to Mars in our lifetime? You said yes. Within the next few
Yeah.
decades, possibly the next decade. How far off are we from colonizing
Mm.
Mars or having people there long term?
Yeah.
Um, what's give me a timeline on your best guess for that.
So I'm glad you asked, because I do think it's really important to make a distinction between those two things, which we sometimes kind of will gloss over
Yep.
that distinction, and it's a really important distinction. So it is very different to talk about sending people on a mission to Mars where they are going to spend some amount of time there, and then they're going to turn around and they're going to come back to Earth. That's what we are all used to with human space exploration. Every human mission to space that has ever happened has been the plan. We're sending them somewhere and then we're bringing them back.
Yep.
Hopefully bringing them back safely. That's always the plan. Um, the idea of going and actually living on Mars or any other place in space is a completely different model, and it's one that does come with a whole lot of things that we really need to talk about, because like some of them we might be ready for, others I would argue we are very much not ready for them.
Yeah.
So basically the point that I try to make in the book, and it's one of the main reasons why I wrote this book, was to try to make it clear that I don't think we're ready. I don't think we're ready for living on Mars or any other planet. I don't think the idea of settlement of space, or colonization, if you want to call it that, like whatever, the idea is of going and not coming back. The plan is to live there, have your family there. That's where you live now. There's so many reasons why I don't think that is something we should be planning to do anytime soon. Now, there are people that will disagree with me on that, and I've talked to many of them, right? So
Sure.
so that's not necessarily a popular opinion in the space community. Certainly, a certain pockets of the space community, but I think it's important to have the conversation, because the fact is, people are working towards that as a goal in the near term future. And so I really wanted to raise awareness with this book, so
Yeah.
that we're having these conversations like you and I are having now about what does that really mean, and what are the risks, what are the challenges, what do we know, what do we not know, and are we ready for that future?
I mean, it was so eye-opening when you laid it out in the book. Like like you said, there is a distinction between going to Mars and coming back and settling there. And I've never thought about it before, but like when we settle there, it's almost like, okay, we can't really visit each other. There's going to be no physical contact. You're not going to come visit Earth. We can't come visit you. There's differences in our immune systems, in our biology, and our environments that could be lethal if we
Yeah.
interacted from this point forward. Like I've never even considered that before, and that was just a fascinating thing to consider when talking about going to Mars and settling on Mars. Because you see, with Elon Musk always talking about, we have to expand, we have to colonize, we have to grow our presence elsewhere in the event of a disaster here on Earth. I mean, it was eye opening to consider that.
Yeah, I think there are just a lot of things that people don't necessarily think about, right? Like you brought up the immune system. Like I think that's something that we really need to be very clear about. Like if we go and live on Mars and start having kids there, a child born on Mars is going to grow up in an environment that only has a tiny fraction of all of the microbial life that we are normally experiencing and interacting with on Earth all the time. Every baby that's born, when they take that first breath, they're breathing in all of these bacteria and viruses and things that, for the most part, are not harmful to us because we have an immune system that can learn how to fight them off. But if you are never around that, and then you come back to Earth, and then you take that first breath of air after stepping off your spaceship, you're going to be exposed to all sorts of things you've never had any way to be prepared for. And so I really worry that actually infectious disease and microorganisms could be the thing that make that future not realistic. I think
Yeah.
moving back and forth between planets, that's not the only reason, but that's one of them that I think, yeah, people just haven't necessarily thought this through clearly enough, and it's super important that we do.
One thing that we hear talked about a good bit, but I think in like mainstream conversation, we don't talk about the long term impacts of staying in space for a certain amount of time. And we know what space does to the body. It was Scott Kelly, right, who spent a year in
That's right.
space in
Yeah,
the
that's right.
International Space Station. We know
Yeah, yeah.
what that does to the body. We know DNA changes happened. Um, in him, there were vision changes within his eyes, bone density, all of that kind of stuff. Also, side note, if his DNA changed, and this might be a stupid question, like is he technically like still a twin?
Yeah, yeah. I've heard that question before. Yeah. So I know it's fascinating, right? So I mean, that was the cool thing about that twin study is that yes, he spent a year in space, and we studied everything about his body that we could at the time, But then comparing all of that with his identical twin, Mark Kelly, who was staying on Earth during that time, that was such a cool setup for an experiment, and so I was really honored when Scott Kelly agreed to write the foreword
Yeah.
for my book. He was the perfect person, I think, to do that because he could speak from experience about what it was like to be in space and to the challenges and also what can we learn and how will we think about Earth differently if we're living on Mars. But yeah, to your question, like if his DNA has changed. I thought you were going to ask, like, is he still the same person? But yeah, is he still an identical twin? What I would say is that, identical twins are not genetically identical. They are very, very, very similar genetically, but every individual has a few mutations that just happen.
Sure.
Basically, every time a cell divides, there's a chance that the cells make an error when they're copying DNA, and that can lead to a mutation. So even by the time they were born, they would have had a few very small genetic differences in some of
Okay.
their cells, at least. And so I would just say this is sort of like a further exaggeration of that process. So it did make him that much, tiny bit more different from his identical twin. It's probably part of why, like, if you happen to know any identical twins, like you can usually tell them apart, right? They
Yeah.
don't
Yeah.
look exactly the same. Partially that's genetics, partially that's like how our bodies develop is not only based on our DNA, it's based on other factors, in our environment and other things. But yeah, it's a good question actually, because yeah, it's not it sounds, I think, probably scarier than it really is to the idea
Sure.
that his DNA changed, but it is also relevant because it changed because of the conditions of space, and we need to understand that process and think about what it would mean for people living their whole lives in space.
So he's born with his DNA. It
Yeah.
changes in space over that year. He comes back
Mhm.
to Earth. Does it change again? Do we know if it went back to what it was before? Did it change even further from that point?
Yeah, so actually, I should distinguish between two different ways in which we documented changes to his DNA.
Sure.
One is to the sequence of his DNA, the ATCG that like makes up our DNA sequence, and that's usually when we talk about our genetics or our genes or our DNA. That's usually kind of what we mean. And in his case, yes, there were some examples in which the sequence of his DNA did actually change. There were basically sections of his chromosomes that got sort of like copied and pasted elsewhere or turned around backwards. Those are specific types of mutations that we kind of know about. And those, as far as we know, would not go back to normal when he came back to Earth. Those are
Mm.
permanent changes to his DNA. And that's really important to recognize. At the same time, there's another kind of change that can happen, which is what we call epigenetic changes. This is changes to like if the DNA is doing its job of making proteins. That's like what genes do. They make proteins. Proteins go and do all the jobs within the cell and the body. And there's ways in which the body can sort of turn on genes and also turn off genes by adding other chemicals to our DNA. And that happened to him in space too. Like some of his genes were basically turned off or turned on by these chemicals. And so we can see those changes happening. Um, but we also can see them going back to normal after returning to Earth.
Got it.
And that, in a sense, isn't actually all that surprising because our body experiences those kinds of epigenetic changes during other kinds of stressful things. Like if you get really sick, or if you experience a famine, or other kinds of sort of things that are stressful to your body can cause epigenetic changes. So of course being in space is stressful in many
Sure.
ways. And so in that sense it was really cool to see, but I would say not terribly surprising that we saw those epigenetic changes, but they are reversible.
So for the DNA changes, and I have a point with this, we're going to go back to the evolution and being in space even longer term.
Yeah.
But for the DNA changes that don't get reversed back to what they were before, is that what evolution looks like at a very microscopic level? Like is what we're witnessing with him during that year, like his body evolving, and is that like how evolution really begins? That
Well,
might be a
yes and
stupid question,
no, it's
but
actually it's a really good question because the answer is yes and no. So mutations are at the heart of evolutionary change. The way that if we look around, at all of the biological diversity on our planet or that has ever existed, right? The ultimate way that you get new forms of life is by mutation. But it's mutation that gets passed on from one generation to the next. And it's mutations that are beneficial, that are sort of retained by natural selection, or even sort of like encouraged by natural selection, right? Like any variety that comes about that's like, oh, this is a helpful change, right? Natural selection is going to make that
yeah.
change more common in the next generation. But we actually define evolution as change over generations. So by that definition, any individual can't evolve. Like, I live in Houston at sea level. And so we like to go up to the mountains in the summer, like in Colorado. And when we go up there, of course, the first few days it's hard to breathe because the air is thin, but then after a week or so, it's easier, right? And it's
Yep.
because I didn't evolve. I would say acclimated. I adjusted to the thin air by doing things like making more red blood cells, and like there's things that the body can do to adjust. And you could even have some epigenetic changes that are happening as a part of that. But if I don't pass those changes on to the next generation, then it'll never result in evolutionary change.
Got it.
So where do the mutations that do result in evolutionary change come from? Well, they could come from some of these same sources. Like, in space, it's radiation that is largely driving
Mm.
these mutations. Radiation is known to cause mutations. That's why when you go get an X-ray, you put a lead vest over your body so you don't get mutations in the cells that that are vital organs, or over the cells that are going to potentially make sperm and egg. Because if those mutations happen, then they can be passed on to your kids. And that then would be something that could lead to evolution. So it matters which cells, and it matters kind of when those mutations happen. So it's not a bad question at all. It's actually a really important one to ask. But yeah, at the end of the day, mutation is what creates variety and new forms in evolution.
We know from that experiment what happens with the body in space, but what further changes could we expect from just going to Mars and coming back? And then what are the changes that we can also expect if we were to colonize on Mars? I know that's a loaded question. There's a lot that goes into that, so we can break it down any way you want. But I'm just curious what the differences in our bodies would be from just visiting and then also staying over there long term and colonizing Mars.
Yeah, great question. So if you and I got on a ship tomorrow and we flew to Mars, first of all, the journey there is going to have an impact on our bodies because we're going to be in a weightless environment for like 6 to 9 months on the
Yep.
way there. It takes a long time to get to Mars. We know that being in a low gravity or a weightless environment causes the muscles to weaken, the bones get more brittle, the fluids are moving around in our bodies, our eyes are feeling pressure from excess fluid in the upper body, and that might make our vision worse. There's all sorts of things that are happening then. So then you arrive at Mars, and now, assuming the landing goes well, let's hope, we are now exiting our ship, and we are in a one-third gravity environment. So, there is gravity, but it's one-third what we would experience on Earth. So you would feel lighter. You would feel, assuming that you did your exercises every day on en route, which you'll need to do so that you don't lose too much of that muscle strength and bone density. You would actually feel really strong because you only weigh a third as much as you did on Earth, and you still hopefully still have some of that muscle strength. And so, you'd be like, feeling really, really powerful. But then you would be adjusting as you're there. So you're in this reduced gravity environment. And it's actually an interesting point that we don't know what being in a one-third gravity environment does to the body. We can guess because we know what happens in 0G. And of course, we know 1G on Earth. But we don't actually know what happens in a partial gravity environment for any long stretch of time
Yeah.
because the only people that have ever experienced it for, longer than just a few seconds, which you can do in a plane, free fall in a plane, but people who have actually experienced partial gravity are the only ones are the people that walked on the moon. There's only 12 people that walked on the surface of the moon in the 1960s and 70s. And the longest that they spent there was about 3 days max. And many spent less than that. So what happens to a person that's in a partial gravity environment? That's 1/6 G on the moon, so it's not even the same as Mars. We don't know after that what happens. Do you still have weakening muscles and bone density loss, or is 1/3 G kind of enough for the body to kind of act
No.
normally? That's actually one of the things that we still need to figure out. So that's what happens to us immediately.
Yeah.
What happens, as you said, if we're there for multiple generations? If we're actually living on Mars, having kids, what happens to subsequent generations? And this is what really sort of the meat of a lot of what I write about in the book is
Yep.
trying to think through this. And again, there are things that are speculative because we don't know. No, experiments have actually been done. But I think there's things that we can apply from what we know about similar types of situations here on Earth. And so, one of the things that I point out is that childbirth is likely to be particularly dangerous to people on Mars. Because if you think about like a person who's spent their whole life on Mars, like a woman who was born there and then, gives birth to a child, she's going through pregnancy with having had reduced, bone density, presumably, right? And now she's carrying a child and now going through childbirth, which is dangerous enough as it is
Yeah.
on Earth. I know you've had some episodes talking about that.
Yeah.
And
I was just
so-
thinking about that. I was like,
Yeah.
I was just thinking we can't get
Yeah.
a grasp on maternal mortality in America.
Exactly. That's
How
right.
are we going to protect pregnancy across the
Yeah.
cosmos?
So all of the challenges that we have with pregnancy and childbirth on Earth now, multiply that by the complications of being in this environment that we have our evolutionary history has never had. One thing that has never changed is the force of gravity. That's, all different sorts of environments on Earth, but they all have the same gravity, basically. So I think that's a real challenge and something that we need to be really clear and upfront about. But because of that, I think it's likely that people would try to do whatever they can to make childbirth safer. One possibility is maybe all of the births are done by C-section. And maybe that's just the safest way to, for mother and child. But if you have 100% of births that are C-section,
I
that that creates a different scenario, right? Now you have a situation where the human head no longer is constrained by having to fit through the birth canal. That's been a major constraint throughout human evolution. As our brains got bigger, our heads got bigger, as we were evolving, and that was one of the real sort of like challenges in the history of human evolution. If that's not the case anymore, the head might start to actually get bigger. So you could actually have future generations born on Mars that have larger heads. Perhaps that means larger brains. Who knows what that means for
so
intelligence?
these like images of aliens with these large
Right.
heads and small, like that's a that's a real possibility.
That's one of the sort of, interesting outcomes of thinking through the logic of this. And what we
Yeah.
know is that, yeah, I think it actually is. And with a lower gravity environment, your body might be able to support a larger head without it being, a real challenge. Like think about the, neck strength and back and support and all of that kind
Yeah.
of stuff. So that's just one example of like thinking through the evolutionary consequences of the challenges of the environment on people actually allows us to make some predictions about possible changes that could take place.
And I don't mean to be graphic, but I'm just thinking if it's fully C-section on Mars, if that's the reality that humans are faced with in the future, what does that do to our sex organs? If it's not being used for its intended purpose here on Earth, does it evolve in a way that the reproduction looks different on Mars? Like that's where my mind's
Yeah, that's
going
very
also.
interesting. Yeah, that is a very interesting question. Yeah, and we actually here I'll put on my evolutionary biologist hat and say that if you look at how species change, if you just look across all of the like diversity of life, and particularly this is true for animal life, often one of the first things that changes as new species evolve is their reproductive organs. That is actually like I work with insects. That's my training as an evolutionary biologist is working with ants. And a lot of insects, if you want to tell species apart from one another, they might look identical in every way except for their genitalia. That's like the only difference between them. And that's because that is one of the things that tends to evolve the most rapidly. So there
Yeah.
is actually a precedent for that, for what we know about how evolution works.
Ah, that's fascinating. I could talk about this for hours, but I know we're running up on time here in a few minutes. But I do want to ask, with the amount of unknown that we have not studied, that we just don't have an answer for, that you've laid out perfectly so far in our conversation. There's just so much that we just don't know. How does moral and ethics play into this? Like, is it moral? Is it morally and ethically just to send people as experiments because we need to know if they're willing to be those subjects, or is it not worth the
Yeah.
risk of trying to find that out? Like, where's the moral and ethics come into this conversation?
I think these are some of the most important questions we can be asking right now because we're at a moment in which the technology is getting to the point where this is doable, and our knowledge of the biology is I think behind it, but not that far behind it, and we do have the potential to catch up. In other words, we have the possibility of actually doing this and sending people to go live and have kids on other planets. So to me, we have to be asking these questions about ethics. And I think we need to be having these conversations now. And again, it's part of why I wanted to write this book is to be able
Yeah.
to engage in these kinds of conversations. I think we need to think about this before it's possible to start, loading ships and sending people off. So, yeah, I think part of it gets back to the motivation of why are we wanting to do this in the first place?
Yeah.
Because if, for example, if we all decided that it was absolutely necessary for humans to live on Mars, then we could ask like, okay, well, how can we do that the most safely? How can we, minimize suffering? How can we, make sure that there's, equal opportunities for all people to go and to, be well when they're there? But it's different to say, well, it's not necessary to go, but some people might want to. And then ask, well, what happens to those people that choose to go, or maybe some people are forced to go, right? Those are all very different ethical scenarios. And so I think it does force us to ask the question of like, well, why are we even talking about going in the first place? And so, there's actually all different reasons that people give. To me, the one that ultimately I think is like the one that resonates the most for me is basically the idea that, and you brought this up earlier, like if we don't, then in the long run, it might threaten our future. Like we might just get wiped out by some disaster that happens here on Earth. If, humans only live on Earth and there's an asteroid that strikes the Earth and wipes out, most life on Earth. We know this has happened in the past. It's what killed the dinosaurs. If that were to happen again, it might threaten our existence. So,
Yeah,
to me, that's the sort of most convincing argument.
sure.
But it doesn't require us to say that we need to rush into it. Like we don't know about any asteroids that are on their way here now. And so I think we can be moving forward towards that possible future by doing research, by pushing as we are doing with, the technology to get us deeper into space and learning about what happens
Yeah.
to our bodies and minds when we go, but without saying we're going to go and experiment on children. Like to me, that is too far.
Yeah.
I think that is a line that we need to be very clear about and say that would not be, ethical to
Yeah.
send people into an environment where they're bringing a child into the world who might not have a good chance of a healthy outcome and quite frankly might be stuck there even if they do survive because it might be too dangerous for them to come back to Earth.
Yeah.
I think we need to know that before it would be responsible to allow people to go and have that happen.
I'm thinking back to our starting point in the conversation being Project Hail Mary, and
Yeah.
thinking back on that movie, they address that, and not to spoil it for anyone, but they address that ethics and the morality behind the decision making so poignantly and beautifully, under certain scenarios that they find themselves in. And then I think they wrap it up perfectly at the end, that it's not some clear cut path to getting this morally and ethically just and right answer. There's gonna be ebbs and flows, and it's gonna take experimenting. And I mean, it's such a fascinating thing to think about. It might feel
Yeah.
ethically and morally unjust right now,
Yeah.
but 20 years from now, how does it age? 50 years from now, how did we benefit? How did it age?
Yeah.
So that it's an interesting thing to think about for me.
Well, and in the movie, and again, I don't no spoilers here, but there is a reason why they feel motivated and compelled really
Yep.
to go and take risks that they would otherwise not probably take, right?
Yep.
And so that's why I was saying like if there were external factors that were sort of like forcing us that we need to go and get people living on Mars, that does change, I think, the balance between risk
For
and
sure.
and what we're willing to accept.
So if I were to ask you, are we trying to evolve too fast? Your answer would most likely be yes.
Oh, well. So I guess to tie it back to evolution, what I would say, this is really the central thesis of my book, is that if we do that, if we decide that we're going to go and live on Mars, and there are people, having families there, and we've got multiple generations that have existed on Mars, we should expect that they will change. We should expect evolution. That's basically the main argument I try to make. Basically, are we evolving too fast? Well, we are actually evolving on Earth right now. My first book was all about the ways in which human evolution is still happening today. I wrote that book 10 years ago now. It was called Future Humans, and it's all about like how we are still evolving, but the ways that we're evolving today on Earth are different from how we've evolved in the past in many
Mhm.
ways. So we're evolving. We may even be evolving fairly quickly. But if we make the decision to go and live elsewhere in space, it will put us on a different evolutionary path, or it will put the
Yep.
descendants of those founding pioneers on a different evolutionary trajectory. So we do have some choices that we can make, and the consequences of our decisions will influence future generations. That's always true, but it's true from an evolutionary standpoint if what we're talking about is going and settling other planets.
I have 50 million more questions that I want to ask, but unfortunately, I do have to ask the final one now.
Ah,
Scott, what is it that you're not wrong about?
well, I would say what I'm not wrong about is the fact that if we leave Earth and if we go and settle on other planets, that it will change us. What we know from, the whole study of evolution on Earth, all of the incredible richness of the biological diversity we have on our planet, it shows us that anytime you take a small number of individuals and you put them in a new environment, and especially if that environment is isolated, they change, they evolve, they
Yeah.
adapt. And that's a process we actually understand fairly well. And so we should expect that if any people ever do the same by leaving Earth and going to live on the islands that we call planets, those future generations will adapt, they will evolve, they will change, they will not be the same as us.
Okay, I lied. This is a final question. I have to follow up on that. I have to follow up on that because I know you address it in the book, but for the audience, at what point do humans become Martians in that process?
Yeah. Yeah, I think it's a great question. I chose that title, Becoming Martian, for a variety of reasons. I think it's evocative and it's
Yep.
provocative, but it's also, you can interpret that in so many different ways, because I think, sure, there's the biological definition that I explore in the book by, getting into, well, what is a species? How do you actually like define, okay, this is a species and this is a different species, and when a new species is evolving, at what point has it become a new species? Those are all relevant, important questions for asking, when would we no longer be Homo sapiens, but be a different human species that lives on Mars? But I also think that there's another element to it that would happen maybe even faster, and that is, how would people see themselves? How would they
Mm.
identify, right? Like, how would future generations born and living on Mars think of them? Would they think of themselves as being Earthlings, right? Of the planet Earth, or would they think of themselves as being Martian? And this is where, like, there's so much science fiction. We talked about Project Hail Mary, but there's so many other examples too from science fiction where authors have thought through this, right? I've been enjoying The Expanse. This is great, series on Netflix, and there's books as well. And so, part of what you get into there is this idea that, like, yes, there could be biological evolutionary change, but it's also how people view themselves.
Yeah.
And so I think that would happen fast. I think that cultural change, that identity, people who were born in that place and have grown up there, it'll have its own culture, might have its own, language and traditions and all of those rich elements of what it means to be human, that they will identify, I think, as being Martian at some point, and it probably won't even take that long.
That's amazing. Scott, thank you so much for coming on and sharing your expertise in your book and having this thought-provoking conversation with me. Genuinely, this was everything that I wanted it to be and more. I know the audience is really going to appreciate this, and I hope we can have you back on in the near future to continue this conversation. I appreciate you so much. Thank you, thank you, thank you.
Well, thanks so much, Chad. This has been an absolute blast. And yeah, I'd love to come back and talk anytime. So thanks again.